So you have discharge. This is the data that you need. Water pressure that's here is 100 kilopascal. You have the diameter of the pipe, 20 centimeter. And what else? Volume of the bend, which is this one. Probably you need it. And the weight. Why you have the weight? Because you are working on forces, so you need to consider all possible forces. Sometimes the material is very light, and it says that just ignore the weight. But here it seems that this bend is pretty heavy, so you should consider the weight. So before you start to solve that, as you remember, all forces rho Q V2 minus V1. The forces that you need to consider. First, weight. So here you have weight. Pressure. This is P. But pressure is not force. You need to change it into force area. If I call it number 1, I would say P1A1. So I have another one here as well, P2A2. And what else? These are all I have. And Ry, Rx, the reaction force. So I want to see what's the reaction force. So one here, Ry, Rx, W. That's the equation that you should use. And one important note. Whenever you have something like that, pressure is always into the section. So if you have both pressures are into. Don't say that this is exit, this is inlet. So both are into the cross section. Pressure, forces always act toward the control volume. What is your control volume? The definition from fluid mechanics. The volume that you consider and enclosed, and you just look at that. No outer things. So it seems that I should do it twice. One for Rx, one for Ry, because I have two directions. So I will start writing the x's. Rho Q V2x V1x. I don't need you to mention it, but if you write it, that's even better. Which direction are you considering as positive? So the one that you can see here, I consider this one as positive, left to right. For fx's, what do I have? I have P1A1, P2A2, and Rx. So all positive based on what I consider. Do I have P1A1? I think I have. Let's back to the question. I remember I have pressure, right? And area. I think I have area as well. Yeah. So what was P1? 100 kilo. What was A1? Pi. What was the diameter? Remember that? 10 centimeter. Pipe diameter, 20 centimeter. That's correct. 20 centimeter. Area, P1. So I think I have the number here. 3.14 kilonewton. I think we all agree that P2A2 is the same because it says that pressure, 0.1, 0.2, it seems that both the same. Area of the pipe is constant. So it means that you can do the same and both are same. Back to the equation, look at that. I have this guy. I have this guy, rho. I know about water, but I don't have these ones. So I need to find them to be able to find this, because the purpose is to find Rx. So for velocity, I know that it's discharge per area. Let me back to the question. I have the discharge here. 0.4 divided by area, which seems that it's going to be that one pretty fast. 12 meter per second is a pretty fast for a pipe. So I think I have everything right now because V's are equal as well. So P1, A1, P2, A2, Rx equal to rho Q. That's all I have. P1, A1, 3.14. That's kilo. Same here, that's kilo. Rx, I need to know it. Raw water, the solution that I have considered 998, 1000 is correct even. So that's raw. Discharge, you have it. Velocity at point 2, 12. Velocity at the other point, same. Water exits here. So velocity is negative at the second point. Here, but the velocity is in this direction. So it is positive, but I have a negative from the equation. So if you solve it, you will find Rx. Again, for this one, look at that's how it goes in, how it goes out. So velocity at this point goes in, positive. So I consider it positive. This negative is because of the equation. Here, water exit, so negative. I will put negative here. Otherwise, it gets 0. Doesn't make sense. So see if you can find Rx here. Hello, Newton. How much? For the conservation of momentum, the direction is very important. In case that you make mistake about the direction, although you calculate each component correctly, that would be a mess. So again, pressure always toward, but velocity depends on if it goes in, if it goes out. Uh-huh. And did you find it? Depends on how do you look at it. Yeah, negative. -10. Yeah. But it's negative. So you can show it by negative or says that this is the direction, both correct. Number? No answer? That's the solution. And for y direction, this is the solution for y. Actually, this is for z, which doesn't make even sense. That's the 2 direction. So it just added one line to say that, okay, we don't have any z direction thing. But this is for y. Follow me here. It says the same equation. But if you look at that, we have just ry here, w here. There is no velocity in y, no pressure in y, nothing. So this is equal to 0. So you just have ry equal to, or I would write like that. This is equal to 0. So ry is equal to this one, which you have the ry. Yeah, ry, and you can find it here. Yeah. Am I right? So wait. Does it give me the velocity in y direction? Rho q. Back to the question. Pipe bend width be heavy, bend volume. Okay, got it. So this is the weight. As you can see, it gives you the volume. So you should need to consider that one as well. Gamma V gives you another weight as well. So this is for